So in this video, I'm going to show you how to find or derive the derivatives of the trigonometric functions from first principles. Right. So this is the work that is done in first year in university or in college in NQF level 4 and so on. Right. So let's see. How do you find the derivative of sine from first principle? So here we're going to do d dx of sine of x, and then d dx of cos of x. Then we're also going to do d dx of tan of x. And then the others will also follow similarly. Okay, so how do we do this? Well, you need to know how to do what is called compound angles in order for you to be able to do the derivative of the trigonometric functions from first principles. And also another thing to note is that the x here is in radians rather than degrees. Okay, so you can't use this formula when you have the x in degrees. Now, let's go to important also to note, radians are sort of a proxy for real numbers. In fact, you express them in real numbers. So that is why we can be able to then do calculus with this. So let's go without wasting time to the derivative of sine. The derivative of sine of x with respect to x from first principles will be limit of the difference quotient, right? The difference quotient is the f of x plus h minus f of x over h, which is basically just the gradient of the average gradient between 2 points that are having a difference of h between the x values, right? And then we make this gradient get closer to the gradient of the tangent at the point x. But anyway, that's a discussion of how we get this formula. So I'm not going to go deeper into that. But when you find the derivative of a function for first principles, this is basically what we do. But because our function is not f in this case, we are going to say what? We're going to replace the f of x with sine. So we're going to have sine of x plus h, which is basically a compound angle. Hence the need to know compound angle formulae. Right, so that's what we have. Now, with our knowledge of compound angle formulae, if you don't know them, there are videos that we've created. You can go check them quickly. You would have what? Sine x is secant c, or psychocosine. So sine x cos h plus cos x sine h minus sine x over h. And then if you check here, sine x, common factor, we can take it out. We have the limit of h goes to 0 of sine of x into cos of h minus 1 over h, over h plus cos of x sine h. Now, when this is like this, we can separate the two parts at the top into different fractions and distribute the limit. So here we assume that you know how limits work. The limit of a sum is the sum of the limits. So, well, that means we are going to have what? Also, we see that the sine x doesn't have h in it. So we can take it behind the limit as well. So that means we have sine x, the limit of h, the limit as h approaches 0, of the cos of h minus 1 over h plus the cos of x also doesn't have an h in it. So we're going to take it behind the limit as well. So we're going to have what? As h approaches 0 of sine h. Right. Now, we're taking the ones that do not have h behind the limits because then they are like constants, basically. Remember, the limit of a constant multiple of a function is the constant multiplied by the limit of the function. All right, now, from here, we have the assumptions that we have made that I didn't mention here, but we can take them by faith here. We have videos where we prove them. But what we have here is this limit here goes towards 0. And this one here goes towards 1. So we can say, but limit as h approaches 0 of cos h minus 1 over h equals 0, and limit of sine h over h as h approaches 0 is equals to 1. Now with that, with these two equations here, then we get therefore the d dx of sine of x then equals sine x times 0 plus cos x times 1, which is basically cos x. And so we know now that the d dx of sine x equals cos x. Now,